Okay, so let's look at some ideas here before you come back to class tomorrow. This is the second day of 2-2 notes. Looking at your test booklet, you should have already gone through all of these vocabulary, including the keywords here. So for truth value, all it says is that any statement can have a truth value. It can either be considered true or it can be considered false, which we've talked about somewhat before. Look at this statement right here. If today is Sunday, then tomorrow is Monday. And that's always true. You're never going to be in a Sunday where tomorrow could be anything other than Monday. Tomorrow will always be Monday whenever it's Sunday. So this truth value is considered true. Negation is a word you've probably already heard. This is the symbol that we always use for negation. What you should have written down for the keywords is the word not. The negation of statement P, any statement, is not P. It's written with the symbol right here, not P. So any statement at all that you have could just be turned around to the negation by adding the word not. So here's a statement, x equals 3. You could negate that or write the negation by saying x does not equal 3. Putting a slash through an equal sign just means not. This means is not equal to. Alright, so I'm going to start off by just showing you some examples to look at. There's nothing to write down right now. We'll come back to one or two for you to write down in a second. But right now, just take a look at these right here. The statement that you're given is an if-then form. And it says, if a number is even, then it is divisible by 2. Before you can figure out these new vocabulary words we're going to be doing, you have to know what the hypothesis is and what the conclusion is. So the words after the word if is the hypothesis. So a number is even. That's the first part of the statement. The conclusion comes after the word then. So the conclusion is it is divisible by 2. That is your conclusion. We're going to have 4 different things that you got to learn here. One thing is called the conditional. That's just your basic if-then statement. And in this case, this statement is already written in that format. So it's always going to be if something, then something else. And we'll decide if it's true or false. So the conditional says if a number is even, then it is divisible by 2. Is that true or is that false? If a number is even, think about all your even numbers. Can we say that it is always divisible by 2? Yes, that's true. Alright, the next thing you need to learn is called the converse. And what the converse does to any statement is it reverses it. It turns it around, makes it go backwards. So the if and then stays in the same place. If, then. But what changes is the hypothesis and the conclusion. They reverse, they go backwards. And the rule doesn't come from the original statement. It comes from the conditional. Writing it the right way then allows you to reverse it. So if it is divisible by 2, then a number is even. That's the converse. And is that true or false? If you can divide a number by 2, then it is even. That's true as well. The next word you need to know is called inverse. And what the inverse does is it adds the word not. It does the negation that we just talked about. So the order isn't changed this time. The if then stays in the same place. The original order is maintained, but what we do is we add the word not to it. So if a number is not even, then it is not divisible by 2. That's what the inverse sounds like. If a number is not even, then it is not divisible by 2. That is also true. Any number that's not even is odd, and odd numbers are not divisible by 2. So that's true. And the last word you need to learn is contrapositive. It's the longest word, so it does the most work. And what it does is combine these two together. The contrapositive reverses the statement and also negates it, adds the word not at the same time. So if and then stays the same, but this time we flip it and we add the word not. So it's going to say if a number is not divisible by 2, then a number is not even. If a number is not divisible by 2, if it can't be divided by 2, then it can't be even. That's true. For the top of your notes, there's a place for you to write this statement. Write this down. A number is positive if it is a perfect square. And please pause as you need to write things down. So we're going to be doing these 4 things. We're going to write it as a conditional, which is if, then. And the if and then never changes. What's going to change is the hypothesis and the conclusions. All right, so go ahead and get all this written down and then we'll work on it. Conditional is your regular if-then statement. Converse flips it around, reverses it. Inverse negates it as the word not, and contrapositive does both, reverses and negates it. So, looking at this statement, the word if tells us our hypothesis is it is a perfect square. So if it is a perfect square, then what would the conclusion be? Then a number is positive. So we're not reversing or anything, we're just writing it in the right order to begin with, like you did for homework earlier. Okay, is that true or false? If a number is a perfect square, then it must be positive. That's true. Whenever you square something, whether it's positive times positive or negative times negative, it's always going to come out positive. When it's true, you do not need to put a counterexample. Look, I'm going to leave that blank. Okay, the only time you do a counterexample is if something is false. So now let's write down what the converse would be. All you do for a converse is you reverse it. You take the back, the conclusion, and put it in the front. So it's going to say if a number is positive, put that in the front now, then it is a perfect square. Just turn the whole statement around. This goes here and this goes there. Now think about that. If a number is positive, then it must be a perfect square. That's false. You can have lots of positive numbers that are not perfect squares. One example for a counterexample is the number 12. 12 is positive, but it is not a perfect square. You can't take the square root of it and get a whole number. The next thing we do is inverse it. We go back to the original order and we add the word not. So we say if it is not a perfect square, then what? Then a number is not positive. If it is not a perfect square, then a number is not positive. That is also false. You can have numbers that are not a perfect square, and yet it can still be positive. Remember, this part has to be true, and this part comes out false. So we can have a number that is not a perfect square, like 20, and we can still say that that number is positive. So that statement is false. And the last one, the contrapositive, reverses it and negates it. It does both, turns it around and adds the word not. So go back to this original order and turn it around while you add the word not. So we'll start with this. If a number is not positive, then it is not a perfect square. Think about that. Is that true or false? If it's not positive, that means it's 0 or it's negative. And if it's 0 or negative, then it can't be a perfect square. So that's true. When it's true, there's no counterexample. You just leave that part blank.